I think maybe I think you have. Go ahead, go ahead.
But is it one of the channels that you are doing the live?
What else is that phone for?
No, this
If you can hear me, good evening. If you can hear me, I want to see a response on the comment section. Say hi. This light here. No. Can I reschedule it? Okay, good. Open it. The light was interrupted, but we are still going to have classes. So the light will not affect us from having the class. So in today's class, we'll be talking about alcohol and carbonyl compounds. I'm going to briefly talk about them. I know that you've been taught in the class. So what I'm virtually doing here is to revise what you already know. Then after which you ask your questions. I can as well throw in some questions. The essence of this class is to just tell you, sensitize you on what you expected to know as regarding CBT for your exams. Then after the live stream, there will be a thorough and detailed teaching using the slides, so that for people that want to enter into chemistry, like people that are in chemistry department and people that will do chemistry in subsequent level, maybe in their third year, final year, or fourth year, or even fifth year for people in industrial chemistry. So this is going to give a very good foundation for your chemistry. So then that's the sense of the slides, so that you can go back there and get a detailed tutoring, self-tutoring. But today is just for general general revision on the slides, laying emphasis on things you need to know as regarding your CBT exam and any of the CAs that will be coming. Sorry for the darkness, light was interrupted, but it will not stop us from getting everything we need to get. So, like I used to say in the classes, chemistry is not difficult, but you can only be disappointed when you cram chemistry, because when the exact thing that was taught in the class was not set in the exam, you might be disappointed. Chemistry is not like English that you're going to cram and know. Chemistry, you have to understand the principle and the basis. When you understand the principle just like mathematics is the same thing everywhere. Just understand the basis and you'll be good to go. You don't need to cram chemistry, and don't be afraid of chemistry. Chemistry is not difficult. Just be dedicated to chemistry and chemistry will be dedicated to you. So if you can hear me, just say hello. If you can hear me, just say hello so we can start. I think I want to start in the 5 minutes time, so I can give people time to join. I know that this network, the darkness is not very funny, but we don't have choice for now because we can't help it. It's still like that. We are good to go. You can see my face, that's what matters. Since you can see my face, I think I'm fine. You see my face, I'm fine. Okay. So I think I'll go ahead and share the slides.
Yes.
I know now.
Are you giving now?
Yes. Okay, let me go ahead and share the slide on alcohol. Let's start the class. Now, alcohol slides. Good, thank you can hear. Now, alcohol is simply an aliphatic compound that have hydroxy functional group Remember, like I said, that functional group is that atom or group of atoms that talks about the activity of the compound. So whenever I see a hydroxyl functional group attached to aliphatic compound, I know that it is alcohol. Now, this alcohol is sp3 hybridized. The carbon is sp3 hybridized, meaning that it is a saturated compound. Having said that, this alcohol is classified into three types. We have primary alcohol, secondary, and tertiary. Now, let's understand the basis of this classification. How do I know different classes of alcohol? How do I know that it's primary, secondary, and tertiary? Now, this is the simplest way to know it. Look for the carbon that bears a hydroxy functional group. Look for that carbon that is connected to OH. How many hydrogen does that carbon have? If the carbon have one hydrogen, we call it primary. If the carbon have two hydrogen, we call it primary alcohol. Remember, it's a carbon that bears a hydroxy. Then if the carbon have just one hydrogen, we are calling it secondary alcohol. Then if the carbon does not have any hydrogen at all, we are calling it tertiary alcohol. So whenever you see an alcohol, a compound called alcohol, and you want to know the class, go and look for that carbon that bears a hydroxy functional group. Check the number of hydrogen that is attached to that carbon. Then it's going to give you the idea of the class of alcohol you're dealing with. Now, difference between alcohol and phenol is that alcohol is aliphatic and phenol is aromatic. In alcohol, we are using a straight chain carbon, while in phenol, we are using benzene. So both of them have something in common. They have hydroxy, the same functional group. But in terms of hybridization, you realize that because alcohol is sp3 hybridized because of saturated compound, but when we have enols, it means that this alcohol has unsaturation. This aliphatic compound is aliphatic, but it has unsaturation. So it means it has double functional group. Number one is double bond, which is unsaturation, and hydroxy group. So these are the two functional group of enol. Enol and phenol have the same thing in common. What they have in common is sp2 hybridized. But in terms of reaction, they undergo different reactions. Enol can undergo a reaction typical of any unsaturation like alkane, while phenol cannot undergo reactions of addition reaction typical of unsaturation. Now, like said previously, that this alcohol have sp3 hybridized. Why? Because their carbon there is single bond, does not have double bond. Just like any other sp3 hybridized, the bond angle is 109. This is similar with ether because ether is still sp3 hybridized, but because of the bonding between the two methyl group, that two alkyl group that is intermediated by oxygen, the bond is higher than that of alcohol. I want to be fast so that we can cover up. Now, in terms of nomenclature, whenever I want to name alcohol, one thing you need to know is, number one, my functional group, which is alcohol, is my priority. So I have to start naming so as to give that alcohol, the hydroxy group, the minimal number on longest continuous carbon chain. So I'm going to follow my right or left, giving priority to my hydroxy group. If you look at the compound that we are trying to name, you realize that my hydroxy group, if I start from my own right, is on carbon number 3. But if I start from my left, is on carbon number 4. So carbon number 3 is lower than 4. So I start from my right to give that alcohol the minimal number. Then when I'm naming it, because it's an alcohol, I'm going to name it as an alcohol. Others become substituents. Now, also when I have a ring, like a cyclo compound, I also make sure I follow the routes that will give them the minimal number. Now, because alcohol hydroxy group is there, so hydroxy group is going to have carbon number 1. Then the other compound, like methyl, that is attached to the cyclohexane, I have to follow the route to give this methyl the least number. If I go clockwise, my methyl is going to have carbon number 5. If I go anti-clockwise, it's going to have carbon number 3. That's why I follow anti-clockwise, giving it carbon number 3, making my hydroxy group a priority. The same thing happens in every naming you name in alcohol. Isopropyl alcohol is a secondary alcohol. Why is it secondary alcohol? Because the carbon that bears that hydroxy group is having only one methyl. These are other classes of alcohol. We can have 2-diol, we can have 3. And cis and trans, whenever you see a compound that have dotted line and stressed line, now the 2-hydroxy group, because of the dotted line, is showing us that it is in trans. But if I'm having the same sign, the same stretch sign, I'm talking about cis. Now, steric effects, the properties of alcohol. Remember, there is hydroxy group. There is dipole-dipole interaction because they have a bent structure with 2 polar bonds. But the most important thing about alcohol is intermolecular hydrogen bonding. Intermolecular is within, something that occurs within the compound. So there is hydrogen bonding occurring within the alcohol. But there is effect of steric in this hydrogen bonding. Now, the more the steric effect, the lower the hydrogen bonding. That's why you can see, remember what is steric effect? We said that when there is steric effect, there is this, because of the bulky group, there is hindrance in interaction. That is why, and for hydrogen to bond with oxygen, there must be space. So when there are too much steric, we are going to have limited hydrogen bonding. That is why primary alcohol have the highest number of tendency of hydrogen bonding, while tertiary alcohol has least. So the more the steric hindrance, the lower the hydrogen bonding potential of a compound. Now, in terms of boiling points, now a question can come: what are which of the following compounds will have higher boiling points? Now, when you see a compound of the same comparable molecular weight, what you're supposed to talk about is the presence of hydrogen bonding, because hydrogen bonding increases the boiling point capacity of a compound. But remember, because steric effect hinders hydrogen bonding, that is why from the second arrow, you can see the more the hydrogen bonding, the higher the boiling point. That's why a tertiary alcohol has the least boiling point, while primary alcohol have the highest boiling point because of increasing in hydrogen bonding. Then if you look at the first structure, where we have alkane, and we have ether, and we have ethanol, you realize that because of electronegativity of oxygen, ether has higher boiling point than ethane. And because of the presence of hydrogen bonding that is very, very prominent in alcohol, you can see the difference between the boiling point of ether and that of alcohol is wide apart. This is because of hydrogen bonding. So understand that hydrogen bonding induces higher boiling point, and steric effect hinders hydrogen bonding. So alcohols are, the common alcohol we know is ethanol. And ethanol can also be obtained by fermentation process. That's whenever you talk about red wine, you talk about fermentation of grapes. When these grapes are fermented, alcohol are produced by fermentation. And that's why they say it's very healthy. This kind of alcohol is not the synthetic one. And the kind of alcohol comes from this fermentation is very healthy for the body, because it is not very hunk. And that's why the percentage, you realize they talk about 7% by volume. So we have some other alcohols. Hallelujah. You can see we have light. We have some other. Let me put on this. Now there's lights, so I can see you very well, and you can see me very well. Now we have some other alcohols. We have methanol, we have propanol, that's propan-2-ol. We also have ethylene glycol. These are some of the alcohol that is very common. Then when you talk about propan-2-ol or 2-propanol, remember I said naming can be any way. I can call this propan-2-ol. I can also call it 2-propanol. The same, that both of the namings are very correct. So make sure you understand the two namings so that when the options come, you will not be stranded. Whether I put the position of all before naming the compound or in the middle of the compound, they're all correct. The windows. Now, this alcohol, the popular production of alcohol you need to know for the exam. I'm not trying to revise your slide. Let's go for the main thing. The most important thing you need to know for in terms of alcohol. Now, when we talk about preparation of alcohol, let's talk about the ones you need, the one that occurs in the lab. You can see I skipped through so many to get here. Now, you should understand how we prepare this alcohol. Number one, remember, alcohol can be prepared from carboxylic acid, from carbonyl compound, from ethers, from alkenes, so many, from esters, from acid chloride. These are the compounds that we can use. We can use to prepare alcohol. But look at the method. Now, among them, there's something I want you to know. Whenever I have double bond and hydrolysis, remember we talked about in the last class that hydrolysis is when you add acid, when you are adding water in the presence of an acid, you're hydrolyzing. In that essence, now, when this bond, let me give you a little mechanism. Somebody was talking about that they are talking about Markovnikov's rule in alcohol. I want to answer that question here. If I want to add hydrolyzed alkene, I'm going to apply Markovnikov's rule. What does this Markovnikov's rule say? The rule says that when I have a positive and negative addendum, now remember this water, when it dissociates, is going to give you hydrogen ion and hydroxyl ion. The hydrogen ion is called the positive addendum, while hydroxyl is a negative addendum. That's electrophilic and nucleophilic, or carbocation and carbanion. Now, when this bond breaks, then the rule says that whenever the carbon that connects the double bond, which is carbon 1 and 2, when I want to apply Markovnikov's rule, it says that this carbon that have the least hydrogen is going to get the negative addendum. But the carbon that have the more hydrogen is going to have hydrogen. It means that Markovnikov's rule say that whenever I have an unsaturated system and I want to add a compound that has both positive and negative species, I should go and look for that carbon that has more hydrogen. I should give it the hydrogen. The carbon that does not have, that has least of the hydrogen, I should give it the negative addendum or carbanion. So in that case, I'm able to form my alcohol by hydrolysis of alkene. Now, another thing I want you to know about preparation of alcohol is reduction reaction. Whenever you reduce aldehyde, you're going to have primary alcohol. Remember, oxidation of aldehyde, primary alcohol is going to give you alcohol. Ketone, whenever you oxidize, you reduce ketone, you're going to get secondary alcohol. Then esters, and whenever acid is the same thing as aldehyde. Remember, I said in the class I had yesterday that when I oxidize my primary alcohol, I'm going to have aldehyde. And normal oxidation does not end until it gets to acid. Light interruption again. Apologies for those. Still continue. Now, since we obtain, remember, oxidation and reduction are reversible reaction. So if I oxidize to get my aldehyde, For me to get my alcohol back, I need to reduce. So that's why reduction of aldehyde gives me primary alcohol, because oxidation of primary alcohol gives me the aldehyde. Reduction of acid give me primary alcohol. So the question is that which of the following compounds cannot produce primary alcohol? Ketone can never produce primary alcohol, but my acid and aldehyde must produce primary alcohol under reductive reaction. And remember, in reduction, you can use hydrogenation is a reductive reaction. So if I want to do reduction, I can add my hydrogen and nickel or palladium or platinum as my catalyst in my reduction. Then, whenever you want to use a mild reducing agent, sodium, lithium, aluminum tetrahydride, and sodium borohydrate can also be applied. But when I want to reduce selective reduction, we are going to talk about this in aldehyde. When I don't want my double bond to be affected, I don't hydrogenate. I use my lithium or aluminum borohydride to do my reduction so that my unsaturated ring will remain, while my carbonyl functional group will be reduced to alcohol. So these are examples of reduction, like we said. Let me go to another thing you need to know. Now, another thing you need to understand in preparation of this alcohol. Now, when I use ester is going to give me two kinds of alcohol. But remember, what is esterification? Now, reversible of esterification is the reduction. Remember, alcohol and acid and alcohol form an ester. Now, when I want to reduce, from that ester, I'm going to reverse them. Then the acid that formed the ester is going to be primary, will end up giving us primary alcohol. Then depending on the terminal aspect of this ester, that will form the other alcohol. Now, if it's normal methyl, it's going to give me methanol. But if it's ethyl or any other compound, so if you look at the structure, you can realize that from my OO, is the acid aspect of it. This other one is the ethyl aspect of it. That ethyl aspect of it is going to form the ethanol. So what I will simply do, at the end of that carbo CH that connects the COO for the ethyl part of the compound, I will just add hydroxy group. Then that COO, being the acid part of the compound, I will just, that last C that connects to double bond becomes my last carbon for the alcohol. So I'm going to have propanol and propanol because of the components of the compound that combine to form the ester. So if what I have is ethyl ethanoate, if my compound is ethyl ethanoate, I'm going to have 2 ethanol. My compound will be 2 ethanol formed. And if it's ethyl propanoate, then my compound is going to be propanol and ethanol. So whenever you're talking about ester, you're forming 2 alcohols. But aldehyde and ketone and carboxylic acid will give you, acid and aldehyde is going to give you primary alcohol, while ketone is going to give you secondary alcohol. Another thing you must know is about Grignard reagents. Grignard reagents is a very important topic that is always being asked when you talk about alcohol. What kind of alcohol can I prepare using Grignard reagent? Now, in Grignard reagent, I can prepare primary, secondary, and tertiary alcohol depending on what I want. Now, whenever my Grignard reagent is reacting with formaldehyde, I'm going to, and the formaldehyde is methanol, I'm going to form primary alcohol. So when my Grignard reagent is reacting with any other alkanol, any other aldehyde other than formaldehyde, other than methanol, is going to form secondary alcohol. But when my Grignard reagent is reacting with ketone, I'm forming tertiary. So when the question comes, which of the following compound is going to give us primary alcohol with Grignard reagents? Remember, the only compound that can give you primary alcohol with Grignard reagent is methanol, while any other alkanol is going to give you secondary. But when you're talking about ketone, you're talking about tertiary. So that's the synthesis of using greener reagents. So let's go to another thing you need to know about alcohol. Another thing you need to know about alcohol is, how do we distinguish alcohol in the lab? Alcohol can be distinguished in the lab using Lucas reagent. Now, a question can be asked, the reagent of Lucas reagent. What is Lucas reagent made of? Remember, Lucas reagent is not just zinc chloride. It is zinc chloride in conc HCl. If there's no conc HCl, it is not complete. So there must be conc HCl in greener reagent. So greener reagent is Lucas reagent is zinc chloride in conc HCl. It cannot be in dilute HCl. It must be in conc HCl. Please be taking note of all these small things, because that's some of the mistakes that students do when we talk about exam. Now, how can I use this Lucas reagent to distinguish between classes of alcohol? My primary alcohol does not react with greener reagents, but it can react after some time by applying heat. Secondary alcohol reacts after some time, then tertiary react immediately. And how do I know the reaction? There'll be like something like a cloudy formation. And at times it can be something like if it's forming something like effervescence, but not notice effervescence like alcohol. So that's how I know that this is alcohol. So if I have my alcohol or non-alcohol, I said which of these following reaction is used to distinguish between classes of alcohol. Number one is my Lucas reagent. It's going to tell me whether it's primary, secondary, or tertiary. Immediately I put my Lucas, I'm going to see reaction confirming it's tertiary. But after a few minutes, it happens, I say it's primary. It never happened. After 5 minutes, it happens, it's secondary. It never happened, it's primary. At times, even if after applying heat, primary alcohol might not react to with greener reagents. Another reaction you're supposed to get used to is the reaction of alcohol with inorganic acids. Now, this inorganic acid, you can use toluene chloride, you can need phosphorus penta, phosphorus trichloride, trichloride and tribromide, pentachloride and pentabromide, they are the same. What is happening here? Remember functional group. So that exchange of chlorine with the functional group. If I'm using toluene chloride, phosphorus pentachloride or phosphorus trichloride, I'm exchanging hydroxy group with my chlorine. And if it's bromo that I'm using, phosphorus tribromide or pentabromide, I'm exchanging my hydroxy group with the bromine. So that's just there. So whenever the question is that you're talking about a alcohol that giving you a product that have a chlorine, you don't need to disturb yourself for the reagent. Either you use your phosphorus trichloride, phosphorus pentachloride, or toluene chloride. Any of them is the reagent. So look at the options of the reagent that is there. Don't go and add and use HCl because it cannot work. So it can be any of this. So the product determines the reagent you're going to use. Now, another thing you need to know about alcohol is that in terms of esterification reaction, what actually happened? How do we form our product? Where is my alcohol my alkyl group coming? How did this ester form? How does acid and alcohol come together to form ester? Now, if you look at the reaction, you understand something. That in esterification reaction, alcohol is going to release hydroxy group, while carboxylic acid is going to release hydroxy group, while alcohol is going to release just hydrogen. Remember, esterification reaction, water is being eliminated, and that's why acid is needed to catalyze the reaction. But in terms of reactivity, you can see that primary alcohol is more reactive. Remember, because of steric hindrance. Tertiary has high steric hindrance, while primary does not have. So that's primary alcohol is more reactive than secondary and tertiary. So in terms of reaction, then there's something about oxidation reaction. Alcohol undergo oxidation. I said in the class I had yesterday The primary alcohol, whenever it starts oxidizing, does not stop until it forms carboxylic acid. So if I want to do selective oxidation of primary alcohol, I don't want to form an acid. My target is aldehyde. What do? I use PCC. PCC is pyridinium chlorochromate. So it's going to end the oxidation to just one step, which is forming aldehyde. But when I'm using permanganate and using chromic acid or any other oxidative agent, I'm going to form carboxylic acid with primary alcohols. Please understand it is very important. Another thing you need to know about alcohol is dehydration reaction. Remember, if you look at the preparation of alcohol, we'll talk about hydrolysis of alkene. If I hydrolyze to form alkene, and if I hydrolyze alkene to form alkanol, if I want to also, the reversible reaction of hydrolysis is dehydration. So when I dehydrate, I'm going to go back to my alkene. So that's why it's a reversible reaction. Hydrolysis of alkene gives me alcohol. Dehydration of alcohol will give me my alkene back. So understand that reaction. It's very important. Now, in terms of this dehydration of alcohol, there's something I want you to know. This dehydration of alcohol, like you can see, the ease of dehydration increases with from tertiary can be dehydrated easily more than primary alcohol, because remember, there are so much carbon that I can remove this hydrogen from in my dehydrative reaction. So the more I have carbon that is attached to the carbon that bears the hydroxy group, the easier the dehydration. Remember, when you are dehydrating, the carbon that bears the hydroxy group is going to take away the hydroxy group. The alpha carbon is going to bring hydrogen. So the more the presence of alpha carbon, the higher the tendency or the ease for dehydration to take place. That's why tertiary can be dehydrated easily more than primary, because of the presence of alpha carbon is more in tertiary, followed by secondary, and is least in primary. Then when I want to dehydrate, next thing I need to consider temperature. The more there is a temperature that will determine the product of my dehydration. If I want to get a product called alkene, I don't need to go with temperature of any other thing other than 170 degrees. But if I want to dehydrate with temperature of 140 degrees, I'm going to form an ether. Dehydration at 170 degrees is going to give me alkene. Now, when I see a compound, I say the product of that compound. If I see 2 mole of alcohol, it's going to give me an ether. 1 mole of alcohol at 170 degrees will give me alkene. 2 mole of alcohol at 140 degrees will give me an ether. Please note it down, because like it was not available in the slide. So, like we said, the reactions of iodoform is also similar with alcohol and carbonyl compounds. The same thing that happened in carbonyl compound happens in alcohol when you're talking about iodoform or haloform reaction. What happens? The compound, for a compound to undergo haloform or iodoform, the compound must have a methyl attached to the hydroxy group or carbonyl compound, which means in terms of alcohol, it's only ethanol and propan-2-ol that can undergo iodoform. Only ethanol. Why? Because in propan-2-ol, like you can see in the structure, that the hydroxy group has 2 methyl attached to it. But in ethanol, the hydroxy group has just 1 methyl. As long as there's methyl attached to this hydroxy group, is going to be reactive with iodoform or haloform. Now, remember, it's an oxidative reaction, because this propan-2-ol under oxidation is going to give you propanone, propan-2-one, and the ethanol is going to give you ethanal, and these are what reacts to iodoform or haloform, as we are going to see in the reactions in carbonyl compound. So I'm going to quickly go through the carbonyl compound. If you have questions on alcohol, can you quickly ask before we go to the next slide? You can ask your question on alcohol before I get to the next slide. Any question? Please respond on the comment section. Any question on the alcohol section for now? If I should proceed, say proceed. Should I go ahead? Hello? Okay, I think I can go ahead with the carbonyl compound. I'm expecting your questions. I've not seen. Please start shifting your questions. Start sending your questions. Start sending your questions. Let's go to carbonyl. Start sending your questions. Carbonyl compound. Why I combine these two topics together is because they're related. If you're talking about alcohol and carbonyl, they have something in common. Okay, thank you. They have something in common. Now, we are talking about carbonyl compound. Remember, carbonyl compound is a product of oxidation of alcohol. So when I oxidize my primary alcohol, I'm going to get what? Aldehyde. When I oxidize my secondary alcohol, I'm going to get a ketone. Why tertiary is stable to oxidation? Why? Because oxidation is addition of oxygen or removal of hydrogen. In tertiary alcohol, there is no hydrogen to remove. That's why tertiary alcohol cannot undergo oxidative reaction. So primary alcohol will give me aldehyde. And remember I said that primary alcohol under oxidation, if I want to stop at aldehyde, I'm going to do selective oxidation by using PCC, pyridinium chlorochromate. But if I'm using normal oxidizing agent, I'm going to get carboxylic acid as a byproduct. So whenever a question said the product of oxidation of a compound, and that compound is an alcohol, ask yourself, what is a class of alcohol? If it's primary alcohol, the answer is not aldehyde, the answer is acid. Except the reagent they added there is PCC. That's when you can get an aldehyde as a product, not acid. So understand the difference, please. Very important. Now, ketone are product of secondary alcohol, like we said. I'm not going to go through the slide. I'm going to talk about the important things you need to know. Whenever you're talking about oxidation, you can see that acid is always added, like a catalyst that helps the reaction to proceed. My primary alcohol is going to give me aldehyde, secondary is giving me ketone. I talk about when I want to do selective oxidation, I'm going to use PCC. In that end, I'm not going to form an acid, I'm going to form an aldehyde. Now, another thing, remember, essence of this is just to go to the most important thing you need for the sake of the exam. Now, reduction of acid chloride. Remember, we are talking about how do I form my carbonyl compound. Number one is oxidation. This one is reduction. When I reduce acid chloride, I'm going to form aldehyde. So the reducing agent is what determines that I'm not going to just use any of the reducing agent like sodium boride, right? No, I'm not going to use them. I'm going to use a reducing agent that is special, which is called lithium aluminum hydrogen tertiary butoxide. This is what I'm going to use to get my aldehyde. That is for acid chloride. Now, we are going, another thing you need to know in this aldehyde is the reactions. Very, very important. The first reaction is a reaction that forms cyanohydrin. This reaction is a very important reaction. Now, what you're going to look at here is that what is happening here? What is happening is that in the exam, the question might be cyanide, or the question might be hydrogen cyanide. Sodium cyanide and sulfuric acid, when they combine together, they're going to form hydrogen cyanide. So what is actually doing the reaction here is hydrogen cyanide. Now, let's split the reaction. If I put hydrogen cyanide and the bond of carbon and oxygen breaks on oxygen, carbon is going to be positive, while oxygen is going to be what? Negative. Then what do? Then it means that the positive sign is going to take cyanide, while the negative sign is going to get hydrogen. That's why we have cyanohydrin. So what does work here is HCN. So in the example, if you're not seeing something like sodium cyanide in sulfuric acid, look for HCN. It's doing the same thing. Then whenever you see anything that has to do with cyanide or nitrile, under hydrolysis, you're forming an acid. There's a question that said, what's the product of hydrolysis of nitrile? Every hydrolysis of nitrile, which is CN, gives you an acid. So just note some of these things. This is what you need to know whenever you're talking about your CBT. And whenever you hydrolyze Grignard reagents, you're going to form an alcohol. Hydrolysis of Grignard reagents is going to give you an alcohol. I'm just giving you some tips you need. Then you ask me your question. Remember, I said whenever we're doing this, the essence is just for you, tutorial for you to ask questions. But now, condensation reaction. This carbonyl compound can condense to form another compound. When I have a hydroxylamine, I'm going to form an oxime. Whenever I have hydroxine, I'm going to form hydroxone. When I have phenylhydroxine, I'll form phenylhydroxone. So any of the thing, I'm going to form a zone aspect of it. If you look at them, hydroxylamine form oxime. What is hydroxylamine? Hydroxylamine. Okay, I'm going to answer the question after this slide. I want to rush through this slide because the slide is small. Then we'll go back to questions. I've noted your question. When you talk about hydroxylamine, you're forming oxime. Hydroxylamine is NH2 and OH. That is hydroxyl that has amine. Then hydroxine is when I have two amine together. We'll call it hydroxine. When they are reacting, they're going to form hydrazone. Because this is a very common question. Please note it. This question is very common and you cannot miss it in any of your questions. So understand what, and whenever you're talking about phenylhydroxine, will form phenylhydroxone. But this 2,4-dinitrophenylhydroxine is commonly known as Brady reagent in the lab. This reagent is used to distinguish that said, I know I have a compound. I don't know whether this compound is a carbonyl compound or acid. When I add this Brady reagent inside that unknown compound, if it turns yellow or orange, I know that this is carbonyl compound. Then I can go ahead to distinguish whether the carbonyl compound is aldehyde or ketone. So Brady reagent helps me to know, to validate that a compound is carbonyl in the lab. So it's very, very important. Make sure you know Brady reagent. You have to know the formula of Brady reagent and what it does in the lab. So whenever I see a compound, 2,4-dinitrophenylhydrazine, what my mind will get is that this is carbonyl compound we are talking about. So that's a reagent I use to validate that a compound is carbonyl. Now, when I'm reacting with semicarbazide, I'm going to form semicarbazone. In the same way, remember, this is an inorganic acid that we use to talk about alcohol. In the same manner, the same thing that happened in alcohol is happening in carbonyl compound. When I want to form a dichloride, I'm going to use phosphorus pentachloride for carbonyl compound. So carbonyl compound can also react with phosphorus pentachloride. Now, another reactions of carbonyl compound is aldol condensation reaction. By what aldol is because the product I'm going to form will have a hydroxy. Now, when two carbonyl compound, either aldehyde or ketone, come together, they're going to form hydroxyaldehyde or hydroxyketone. These are called aldol reaction. And the reaction is initiated by a base. Remember, a base is going to take away acid hydrogen. Then let's go to the mechanism. The first mechanism is using a base to take away alpha hydrogen. What is alpha hydrogen? Every compound that has a functional group have alpha carbon. Alpha carbon is carbon next to the carbon that bears the functional group. So the hydrogen in that alpha carbon is called alpha hydrogen. So this alpha hydrogen my hydroxy group is going to take, because it's acidic, it's going to take one of the alpha hydrogen to form a carbanion. If you remember this last slide, we talked about how to generate carbanion. The first method is using heterolytic fission. Second one is using a base to abstract alpha hydrogen. So that is what we did here to form carbanion. Then the second, remember we are using 2 aldehyde or 2 ketone. So the first carbonyl, we are going to form a carbanion. The second carbonyl, we are going to form a carbocation, so that the carbanion is going to come and attach in carbocation. How do we form the carbocation? A carbonyl compound is going to break heterolytically. When it breaks, remember, oxygen is highly electronegative. So the break is going to move towards oxygen. When it moves towards oxygen, oxygen is going to have a negative center, while carbon become positive. Then remember, because oxygen has negative, carbon is positive. So the negative of carbanion is going to come and bond with the positive of carbocation, and giving lead to the product we have. In this product, my oxygen is still electronegative. Under acid hydrolysis, I'm going to give hydrogen, give up my oxygen that has negative species hydrogen to stabilize it. And at the end, I'm going to form my aldol, which is hydroxyaldehyde. So this same thing can still happen when I want to use ketone to form that. My ketone has 2 acidic hydrogen. I can use any of the acidic carbon to form my carbanion. So I will still do the same by creating a carbon method. When this carbon is attached, my carbanion will come and bond with carbocation, and I hydrolyze to form my aldol. Then when I want to dehydrate an aldol, I'm going to form enal. Which is unsaturated aldehyde. And how sorry. That was a break in transmission. Nigeria factor has played again. So sorry about this. We're almost done here. We'll soon go back to our questions. Please be forwarding your question. Be forwarding your question. Now, difference between dehydration of adult products and normal dehydration of alcohol is that the temperature I need for alcohol is just 170 degrees to form from alcohol to alkene. But in adult, I need a reagent which is sodium hydrogen sulfate and heat. But in alcohol, I need temperature of 170 degrees and sulfuric acid. Please understand the difference. So the reagents for the two are not the same. So that, because in exam hall, you cannot avoid these questions, especially dehydration of alcohol. So I need sulfuric acid at temperature of 170. But when I want to dehydrate 2 mole of alcohol at 140 degrees using the same sulfuric acid, I'm not going to form alkane, I'm going to form an ether. So please understand the difference. Then there's something else called cross-aldol. In cross-aldol, we use both aldehyde and ketone to form the aldol. For your exam, this is not going to come out in your exam, but just for you to have an idea of what is cross-aldol and normal aldol. And in cross-aldol, one of the aldehyde will be without alpha hydrogen, while in my normal aldol, all the carbonyl must have alpha hydrogen. Please understand it very well. Then Cannizzaro reaction. Unlike aldol, Cannizzaro reaction don't need alpha hydrogen. So if there's a compound, they say which of the following compounds can undergo aldol reaction? Go and look for carbonyl compound that have alpha hydrogen. Which of the following compound can undergo Cannizzaro reaction? Go and look for a carbonyl compound that does not have alpha hydrogen. Please note the difference between the two. Nobody will ask you the mechanism at this your level, so don't bother yourself about that. Now, if I'm talking about cross Cannizzaro, I'm talking about aromatic and aliphatic. None of them will have alpha hydrogen. Going back, okay. Now, whenever my cross aldol is not going to form an alcohol. Now, my cross aldol will form, let me see if I can go back to the previous slide. Now, if you look at cross aldol, my cross aldol is forming an alcohol and a salt. Cross aldol cannot form a carboxylic acid. So the product of cross aldol can never be an acid. It can be an alcohol and a salt of an acid. Please understand this. How do we differentiate between classes of between aldehyde and ketone? The most important way of distinguishing them is oxidative reaction. Oxidation in different ways. It can be normal oxidation because primary alcohol can oxidize to acid. Aldehyde can oxidize to acid, but ketone can never be oxidized. Whenever you want to oxidize ketone, it's going to cleave. The bond will cleave away. So it's stable to oxidation. Another oxidative reaction we use to distinguish aldehyde and ketone is Tollens reagent. Assuming in the lab, you've used your Brady reagent to validate that this is carbonyl compound. So how do I distinguish whether they are alcohol or ketone? I'll use my Saver mirror. When I add Saver mirror reagent and there is a change, there's a change in this compound, so I'm going to see something like Saver mirror, like Saver nitrates, like a Saver mirror, a Saver thing at the tip, at the corner of the test tube, which forms Saver mirror. I say that this is an aldehyde. For ketone, you're not going to see any form of Saver mirror. Another thing I'm going to use is filling test. Filling is blue. So when I add a unknown compound and I add this fillings reagent, and I'm going to observe something. What will I observe? I'm going to observe that there will be a deep brick red or brown color. I'll say, wow, this is aldehyde. But when the deep blue color remains the same, it becomes a ketone. Like I said, whenever I want to do reduction of carbonyl compound, when I'm using hydrogenative reagent, that is hydrogen in nickel or palladium or platinum, I'm going to form a saturated alcohol. But when I want to use something like aluminum tetrahydride or sodium borohydride, that are mild reducing agents, I'm going to form unsaturated alcohol. So the reagent I use is going to determine the product I'm going to form. And whenever I have a product which is carbonyl compound, and a reactant is carbonyl compound, and I'm seeing a product being a toluene, how can my aldehyde form a toluene? The reaction can only be clemency reduction. So if a reaction is being written, carbonyl compound giving you a toluene, and they tell you what is the name of the reaction is clemency reduction. What is the reagent I need? I need amalgamated zinc, which is zinc in mercury and conc HCl. In exam, CBT, they can give you zinc and conc in HCl. They can give you zinc in mercury and HCl. So there will be different versions to make sure that you understand the option you're choosing. So if you're not sensitive enough, you're going to choose the wrong answer. Remember, it's not just HCl, it's supposed to be conc HCl. Then, like I said in previous slide about iodoform reaction, for a compound to form iodoform, the compound must have a methyl attached to the carbonyl compound. It can be in form of ethanol, can be in form of propanone, or any compound that this methyl is connected directly to the carbonyl compound. So that's the product that is going to form haloform or iodoform. And how do I know? The color is going to be yellow. In the exam, in your lab, you're going to see it. They're going to give you a iodoform and say which of the following. They will give you a compound and they'll give you iodoform. Then the compound that will react to that iodoform is going to have a methyl. So when you form a yellow crystal, it means that the aldehyde you validated, it can be ethanol, because it's only ethanol that can react with iodoform, or it's only ethanol that is aldehyde that can react with iodoform. In terms of acetone, propanone can do, and so many acetone can do, but in aldehyde is only ethanol. So if the aldehyde, the compound you're working with is an aldehyde, you validated it, it reacts with silver mirror, it reacts with filling solution, but you want to know what is the structure of this aldehyde. Is it primary? Is it like ethanol, or is propanol or whatever? If it does not react with iodoform, it is not ethanol. It can be propanol or butanol. But if it reacts with iodoform, it is ethanol. So this is going to help you to validate the nature of your carbonyl compound. So let's ask our question. Let's ask our question now. Question time. Question time. Question time. Question time. I've explained the dehydration again. Dehydration with temperature, when you're using 140 degrees and 2 mole of alcohol and sulfuric acid, you're going to form an ether. When you're using 1 mole of alcohol and temperature of 170 degrees and sulfuric acid, you're going to form alkene. So that's the types of dehydration in alcohol. So dehydration is removal of water. So whenever you're dehydrating, you're removing water. So I'm waiting for your questions. Ask your questions on carbonyl and alcohol. Hello. Let me see if I can bring past questions. But ask your questions before I start looking for past questions. Question time. Can you hear me? Ask your question. If you have the past question, let's go to the past questions. Question number 42. If you're there, say hi. If you're there, say hi. Hello. Okay, no question from you. Okay. Do you have your past question? You have your past question. Past question. Hi. Past question. Past question. Let's go to the past question. We have question number 42. If you have past question, let's go there. And if you don't have it, say I don't have. So it means that we don't need to go to past questions. Hello? Okay, past question. That question number 42. They say which of the compound will undergo haloform reaction? I want us to answer this question because these are the similar questions you should be expecting in the exam. There's so many things to answer here on alcohol. I don't have, ma. Oh, what do we do? What do we do? What do we do? And that's not how I will send this question online now. So how do I do this? How do I do this? So nobody have past question available online? Oh, what do I do? Okay. Now, this past question was sent to you. So what we are going to do now is that we are going to end the class and I'm going to look for a means of sending this past question to you so that you go through the past questions and ask your question. I want you to ask questions as regarding, it's not about the class today, it's about everything you don't understand in alcohol and aldehyde and carbonyl compounds. So okay, let me ask my own question since you don't have question to ask. Let me ask my question. Let me see the question that can. Oh, there's so many questions to ask here. And some of those questions I can only read it out. Let me see the ones I can read out. Okay, let me read out this one that I don't need to talk too much on. Which of the following would oxidize to propan-2-one? Which of the following can oxidize to propan-2-one? Then, number 1, butan-1-ol. B, ethanol. C, 2-methyl-propan-2-ol. 3, propan-2-ol. Which of the following can oxidize to propan-2-one? Propan-2-one. Is it butan-1-ol, ethanol, 2-methyl-propan-2-ol, and propan-2-ol? That's A, B, C, D. Choose your options so I can explain. We are just going to do few because of you not having the past questions. But what will happen is that I'll look for a means of making the past questions available for you. Maybe if it's possible online, I can do that. But I'll make sure you have it. Any idea of answer? Now remember, in oxidation, propan-2-one is an aldehyde, is a ketone. And for me to get it, I need secondary alcohol, which is propan-2-ol. Now, if you get to exam and you see something that is repeated twice, option repeated twice means that your answer is not far from that option. Look around that option, you see your answer. Now, because there is no question, it means that every question on aldehyde and ketone are very fine by you. So my question is that which of the topic do you think we want to do tutorial on so I can work on what you don't understand? It will make it more interactive because I like an interactive class. Which of the topic do you want us to talk about again? Which of the topic do you want us to talk about? Which of the topics do you want us to talk about? Which of the topics do you want us to talk about that you have an issue with? Can you talk? Can you talk? What topic do you think we can talk about? Hello? Oh. Which topic do you want us to talk about? This light is making this class very boring. Me, I'm feeling bored already. And you guys are making me feel too bored. Okay, in absence of any question, talk to me. Blessing, talk. What do you want? What topic do you think you need us to talk? Eaters, okay, eaters, right? Which other topic? Let's talk about topics. Topics that you feel that is difficult for you to understand. Please, let's ask our questions now. Eaters, which other topic? Because today is gone already. I would have talked about eater. Talk. Which other topic do you want us to talk after apart from eaters? Are you okay with phenols? Are you okay with phenols? If it's only eater, there's no problem. So which other topic do you think you need? You need lights, more lights. You need more detail on. You need more tutoring on. So we can talk about it. Blessing, Adana, talk. What do you think we should talk more about? Tomiwa said eater. Blessing, talk. Anu Oluwapo, I'm not hearing your voice. Vamprik, I'm not hearing your voice. Talk. Hope Friday, I'm not hearing your voice. Akindele, I'm not hearing your voice. Please, talk. It's on the group chat, ma. Oh, let me check the group chat. Is it that you guys don't have access to in chatting here? But I would have preferred us chatting here. So let me go to group chat and see what is on group chat. I want to know the topics that we can talk about. If you understand the topics, I want an interactive class. I don't want to come here and you guys are not talking to me. Please, I want you to talk to me because I leave so many things to come. So eaters is not an issue. Do you want us to continue with eaters this night? Do you want us to talk about eaters this night? If you want eaters now, say yes. And if you want eaters in the next streaming, say next time. Let me hear you talk. When do you want us to talk on eater now? Phenol too, ma. Okay. So we can talk eaters and phenol. That should be another class. Normally, I want to combine eaters and phenol for the next class. So talk. And I don't know whether we should do the class before Christmas. Should we do the class before Christmas? Or we should do it after Christmas? Talk. Next time. Okay, we're going to do it and next time. So far, no question. Okay. Since there is no question, so we're going to, when do you want us to have the next class? When do you want us to have the next class? Phenol will be appreciated. I will talk about phenol and ether. That should be next class. Do we have it this week? Monday is 24th. No, Monday is Christmas already, right? Monday is Christmas. When do you think we can have the class? Okay, you talk about when you think we can have the class, the next class, if you can have it this week, or if we can have it after Christmas or next year. But for real, I want us to finish all the topics you've treated this year. I want us to talk about all, so that next year, when you're being taught the new topic, we'll talk about it. I don't want us to carry any topic over. Okay, we're going to do it next time. When will next time be? When do you think we can do this next time? Now, remember, after this live stream, you can still have opportunity to come and ask your question. Maybe you have to go through it again, then ask questions. That question will be responded to. So your asking of question does not end on this time. It does not end now. You can still ask your question after now. So don't limit yourself and say, I did not ask. So any of the topic that was treated that you realize that something you don't understand, go back to that live stream and comment by asking your question. You'll be responded to. Thank you very much for coming this day. I appreciate your presence. Although some of us are not steady, some of us couldn't make it. That is very well. So if you know you couldn't, people that could not make it, share with your friends, let them go and watch again. And you, if there's anything you don't understand, we'll also make our time to respond to your questions. And remember, I don't want you to live life alone. If you have issues, challenges are so much, so it does not affect you alone. So don't die in silence. Always come around. You can private chat me and I will give you attention. We can talk things over. When you share matter with someone, there's a saying that a problem half shared is half solved. So when you share a problem, that's half the solution. One word or two can bring the solution and healing you need. So don't die alone. No matter how difficult a course the chemistry is looking to you, maybe everything I'm talking is still like story. Then you can see me in the office. If you're having issues, see me in the office. My office is 108, so I can give you attention. If you come, I'm available. I can clear any point you feel that you don't understand, even after this live streaming. So don't feel, after all the explanation, yes, I don't understand this. Don't live life alone. You are not alone. Always be free to ask your question. Some people don't want to ask question here so that they will not see them, they're asking question. Please, don't ever be shy whenever you're approach in journey of destiny. Don't be shy. Don't feel that they will feel I don't know this simple thing. It doesn't matter. Ben Carson was laughed at in the class, but at the end, those people that mocked him came to him to beg because he became their leader. So it doesn't matter now. What matters in future. So make sure you don't shortchange yourself because of your environment. You don't want people to feel or what is not important. Okay? I'm going to talk about phenol and later in the next time. But make sure you be ready to ask questions. Don't allow anybody to shut you up. It's your life, it's your destiny. And in life, all of us are on our own BRT. So don't allow anybody to shut you up. Be bold enough to ask your question. The more you ask, the more you know. So and then what matters is at the end of the exam, you have your A. Whatever that surround the A is not important. All the yabbing, all the mockery, or whatever that came before the A will be forgotten when the A comes. So don't live life alone. Don't be discouraged. Keep moving forward. Keep working hard because success will surely smile at you. Till I see you in the next broadcast. Remember, chemistry is easy and you will just not make chemistry. You're going to do it well. You're going to come out excellently well. Our target is nothing but A. So aim at A. Bye for now.